Hey everybody, how are we doing? I've got the Kahoot up in the background, so let's get it going. Are you in the group? We got GroupMe, we got Discord, we got everything. So people are saying the exam, is it hard to study for? The biggest thing, I think with the exam, and we'll see the grades here soon. We'll see the grades. Well, not soon, but I think with the exam, it's really about like understanding your assignments and understanding the output. So when you think about how you can be successful on the exam, is join up the group, or not the group, join the group too. But here we'll put a 2-minute timer on. 2-minute timer going. Kahoot music in the background. Kahoot. The biggest thing is kind of understanding your output. So when you think about what do you need to know, you basically need to understand the output more than just like the numbers on the screen, which is some of the things we're going to focus on tonight. During office hours today, we did a really good review of all the associate function. And then today, during class, we did a really good review of how to interpret stuff. So we'll also review interpretations tomorrow. So if you're looking for great reviews for the test, interpretation is on the test. Interpretation is 9 points of the test is interpretation, which that's almost 20% of the test, or at least more than 20%. Interpretation is exactly 20% of the test. 9 divided by 45. 9 divided by 45 is 20%. Interpretation is the review, quiz, and response test all multiple choice? Nope. Interpretation. It's going to be multiple choice, interpretation, true, false, all the good stuff right there. Make sure interpretation. We did a big interpretation review today. We will do an interpretation review tomorrow. And we might have, if you are tool, and you are allowed to play this, and if you win, you have earned it. There's $50 for first place. It's all Amazon gift cards. $50 first place, $20 second place, and for third place, $10. I didn't put that in the announcement, but let's do it. If you're 201 and you win, you earned it. So there we go. People getting together. Interpretation Mad Libs, exactly, Lucy. And it's all the practice we need. Hopefully today we showed that we need to make sure we have good interpretations. So I'm going to try to make sure all the instructors graded at a certain difficulty level, so we see kind of an even. Want to make sure the interpretations are strong. If your interpretation's kind of like this, that's not. Oh no. We'll do another questions right now if you have it. Jensen, so good to see you here, Jensen. You got this, Jensen. You're in the Shark Tank right now. You're like, I can do this. You do it. Be massively impressive. I think Jensen's 12-1, right? But you are more than welcome to play. We are glad to have you. I put another minute on the clock. So people are helping out. Discord answers. Message each other on Discord. Start the community. Get it going. We got 1 more minute. There we go. It's right here. We got a fact Google Doc going. Nice. So great stuff. Great information. Great practice. Post this on Discord if you want to. Post it on Discord. How about that right there? What else do we have? We're going to start here in 30 seconds. 30 seconds till the start. There's the disco guy in the background. But the biggest thing is the practice. It's really hard to learn everything the night before the test. So if you feel a little behind on this, like I want to know who at the end of this, I want to know who wins. So if you win, here's one thing I ask of you. So we're about to be a time up right here. We're starting in like 20 seconds tops. If you win, I ask this of you. I ask you to share your strategy. Do you list your class recordings or just office hours? The class recordings are under a link that the students have access to. Good to have you here, Virginia. Good to see you. And so if you're like a UTK student, I can probably send them to you. I don't know. The office hours are live for everyone to see. So all this good stuff right here. So glad to have you here. I invited Terry's sections and Dr. Lee's sections. Is everyone ready to Kahoot? Let's get some I'm ready's in the chat. You guys know that's how we start here. We say I'm ready. SpongeBob. I'm putting I'm ready in the chat. Who's ready in the chat? We're going to start here in a second. Get some I'm readies. Share those links. Thanks for... Yeah, of course, Virginia. Anytime. You can join office hours anytime. You can ask questions anytime. Good to see you here, Christopher and Megna. Please tell me if I pronounce anyone's names wrong. You can be like, Brian, actually, it's pronounced this way. Thank you to multiple students who have corrected me. Carter, good to see you. Let's see. Is everyone joined in? Got all these I'm readies. Paige and Carter, good to see you here. Roderick, everyone. That's got it. Christopher, good to see you here too. We're starting in 3, 2. I'm ahead in the future. 1. Let's Kahoot. Here we go. Who's gonna win? First question of the day is, state your conclusion on the QQ plot for something. I don't even want to say a QQ plot is always this. QQ plots are always measuring this. They're always measuring this. And I know you're seeing this. I know you're looking at this, but read this down here. That's a hint. That's a hint. We'll never remove this from the output. We could ask you in general, like a QQ plot measures what? That's a huge hint. And then it's within the red right here. This is a perfect example of one that is normal. So can anyone explain in the chat? Nice job there, Lucy. How do we know a QQ plot is normal versus a QQ plot is not normal? They're called QQ plots for quantile plots. They measure the quantiles of what we observe versus what we expect due to the normal curves. That's why it's QQ. It's quantiles and measuring the quantiles based on what we would expect if the curve is normal. And so this line right here, this red line is the perfect normal. So if these points are perfectly on it, it's perfectly normal. And then these points are kind of the, as Lucy points out right there, the dotted bands are kind of like the, it's all right. And this one's actually pretty good. It's actually pretty good. And these aren't quite the prediction. Actually, they are kind of a predicted interval for the normal, but don't think of it as like a linear model. I mean, it's kind of like that, but don't think of it too much like a linear model because this is not your linear model. This is only, I want to see it in the chat. This is only being used to do what? This is not like the LM function. This is only being used to gauge what? Because a lot of people make the mistake of thinking that this has something to do with this stuff over here. This is not your linear model. This is only used to check normality to see if your residuals or anything else you're measuring has a normal pattern to it. And this is to check normality assumptions right here, whether we're doing the mean or the median or stuff like that. Big thing right there. Christopher and Snan, everyone, HCT, great job. Carter, great job right there. Who's in the lead? Joyful Snail, joyfully jumping into the lead, but Proud Unicorn. I like Dandy Penguin, though. Dandy Penguin, you're going to win this. Watch this. You watch. Fast forward to the future, Dandy Penguin wins. Here we go with the next question. Compute the expected count for Verizon rarely. Ooh, this is a super tough question. People are like, I didn't have my calculator out, Brian. I didn't have my calculator out. I'll show you how to solve it. People are running to their calculator. We have Verizon rarely. Please tell me I did the mathematics correctly on this. I know I love the names too, Herschel. If you know how to do it, it's pretty quick. I'll show the mathematics here. Grab your calculator if you didn't. This is the calculator warning right here. Click an answer quick. Click an answer. I don't think you lose points for getting wrong. People are just grabbing their phone. Oh, nice job. That was probably a lot of anxiety right there. I didn't mean to cause so much anxiety probably. But great job. So what do we do to get the expected cell count? So to get the expected cell count, we do the following. We have Verizon and rarely. So we go here to rarely. And we go here to Verizon. And we see where they intersect. Now, we're not so concerned about where they intersect, but we're concerned about these numbers. The formula for this is as follows. Row total times column total over grand total. Does this make sense? Nice job, Mubarak. Great job right there, Mubarak, showing the row total times column total over grand total. I ended up not looking at the conditional distributions. Oh, there we go. So does this make sense here? This is how we do this. And what kind of data are we dealing with here? What kind of data are we dealing with? Or what kind of graphical display, I should say. What kind of graphical or data or graphical display? So you're seeing some tips right here. This is not a bad screenshot to know. It's a very, very comprehensive look at the different graphical displays we have. And you are seeing a what display right here. There's a few ways it can be displayed. Well, so if it's singular, you are correct. A frequency table is the one variable. That's the one all the way at the top right there. That's a singular display. So that would be a frequency table would be the singular display, but this is bivariate. So since it's bivariate, it's a contingency table, which is right here. This region right here is the bivariate categorical display. If you're looking at how to read this, this is the intersection of a categorical Y and a categorical X. The top ones up there are just one variable. It's a univariate display. So hopefully this graphic right here can help. We're looking at mosaic plots or contingency tables, which is what we're seeing right here is a contingency table. You'd have to ask, what is your cell phone provider and how often do you have dropped calls in terms of like a category. So really great right there. We'll see who's in the lead. Do not worry. This is way early on and you're here to practice and you're here to learn. Let me just ask this. Would you rather lose the Kahoot or ace the test? As we look at the leaderboard, type in the chat. Would you rather lose the Kahoot or ace the test? Woo! You can't beat Super Dove. I mean, but you could. Maybe Groovy Tiger could beat it. Did I say Proud Unicorn? I think I said Proud Unicorn's going to win. Ace the test. You're right. Ace that test. Don't worry if you lose this tonight. This is for practice. This is for us to see the mathematics, to practice things, take notes. The expected cell count is row total times column total over grand total. Great job, Ashton, right there. Sebastian, good to see you here, Cliff. Super Dove versus Proud Unicorn. Who's going to win with question number 3? True or false? Side-by-side box plots compare a categorical Y and quantitative X. Categorical Y and quantitative X. Categorical Y and quantitative X. I'm sometimes afraid I put the wrong answer on these. Please don't give me a heart attack tonight. Past Brian, please have done this correctly. The answer is... the hint is categorical Y. Because someone's going to be like, wait, what? I know it's a tricky one. I want you to look at this right here. Hopefully, can I zoom over to it? I knew that would get people, and because I knew that's a trick one. The trick one right here is when you think about side-by-side box plots. Side-by-side box plots are right here, and I want you to look at what variable right here. So look at this. Side-by-side box plots have a what X variable. So side-by-side box plots, and I'll show some over here in R in a moment, but side-by-side box plots have a what variable. So I'm going to do the associate function. I'm going to bring up some plots here so you can see, but just be looking at the graphic. So the associate function, if we're predicting height from gender and data equals survey 10. And so I'll show you the graphic here. Figure too large for margins. Exactly. The important thing when you think about box plots, invalid graphic state, really? Really? There we go. Now it's loading. Okay. So let's head over to the main screen. We're on the main screen now, right? Yeah, cool. Does everyone see the difference right here? What is on the y-axis with side-by-side box plots? On the y-axis with side-by-side box plots, does everyone see it? Future Brian, thanks, Fast Brian. Yes, he does. He got it right, but that's a tricky one. I was like, please tell me I didn't trick myself. What is on the y-axis right here? The what variable is on the y-axis? The text might be a little small to read right there. What variable? Figure too large for margins. What variable is on the y-axis? The quantitative variable. Does everyone see that the quantitative variable and the x variable is categorical? So that's a little bit tricky of a question right there. Just write this down. Take a screenshot of this if you haven't. This graphical display thing right here is not a bad kind of, doing this. Good to see you here, Adam. Joining the game. We've got the code up. So the code should be right behind me. Let's head back to the screen. Here is the screen. The code is right there. Join in if you want to play. Let's see who's winning. Super Dove, no. Joyful Snail, Joan right to the lead, but Smart Raccoon, you got this. Let's see who's going to win. It's very few people have gotten every question right. These are tough questions. True or false? Scatter plots compare quantitative Y and quantitative X. You got this. You got this. Not tricky question. If you've taken 201 with me, you should know this pretty instantaneously. Scatter plots contain a quantitative Y, compare a quantitative Y and quantitative X. Scatter plots can compare quantitative Y and quantitative X. Anyone want to put something in the chat? Blank, blank, straight enough. No outliers. Plot doesn't thicken. Some classic stat 201 right here. What is this? Very, very true. Nice job. Yes. Jensen, you're like, I know that. QQ straight enough. No outliers. Plot doesn't thicken. So a correlation. This can be a correlation. This can be a regression. So correlation, regression, all these things are two quantitative variables. Great job right there, Jensen. Thank you so much. We're throwing some 50 points to the chat right now. Points, add viewers, 50 points. Excellent work. Don't worry if you're the one person who get it wrong. You probably misclicked. You got this. Let's do this. Next question. Look at that leaderboard skyrocket. Next question. Who's going to win? True or false? Histograms display a categorical variable. Very, very something. Histograms display a what kind of variable? So, not to give it away. I mean, if you clicked quickly, then you would have got it, more points. But histograms display things like height, weight. You think about what would you display with a histogram. Histograms are always going to display a singular this. Histograms always display a singular this, and they always display a singular quantitative variable. Histograms display one quantitative variable. Probably if we try over here in R to do it, if we type hist and we do something and we try to give it something like gender, it'll say must be numeric. So right there, we can kind of confirm the answer that a histogram must display a quantitative variable. And you can see the count, which is a little bit like bins. I mean, these are bins. We call them bins on histograms, but they actually have to be in order on a quantitative scale here, as you can see behind me. So the histogram is a singular display of quantitative variables. Who's in the lead now? Social Quail joining in the party on the leaderboard. Please ask any questions if you have them. I have 200 kick. We get a lot of kick-ups too. We got this right here. Be talking to each other, be asking questions, be answering questions. Thank you, everyone in the chat. If you are stuck on something or confused, please let me know. But we're just talking about variable types here, and we're going to get into regression and associations in just a second. What is the best way to investigate normality? What is the best way to investigate normality? I'll show you graphics here in a second. We should know instantaneously that this way of investigating normality is a way that will never change, will not change on the data. All of these display quantitative data. Scatter plots are bivariate quantitative data. Box plot or box plots can be univariate or bivariate. Depends on if we're doing a box plot or box plots. You can do stacked histograms, but the QQ plot for normality is the number one way, and I can't trick you with that. What we're talking about right here is, especially when you do the associate function, we were doing Jelly Bean Stay in class, the associate function, so there's all our interpretations. If you want, you could always pause the screen on these. I'll let you come back here if you want and pause the screen here on these. These are interpretations we wrote today in class, and we're practicing. I think everything is displayed right there. So the associate function right here will give us, let's run this one. This will give us side-by-side box plots. Let's test your knowledge. Okay, so what does everyone think about this? Normal or not normal, and why? Normal or not normal, and should we use means or medians then? This is really good practice. Like, start describing these, and where do you see issues or no issues? I think the AI that made this Kahoot is biased towards QQ plots. It's where I see a lot of mistakes. Usually people are like, oh, they might look at this. No, don't look at these. These are the permutations down here. I think we're almost done with QQ plots though. No. A lot of people forget, like, this is a big concept in our class, is testing to see whether it's normal. Normal and means based on the QQ plots, exactly. Mostly normal, a few outliers down here at the bottom. So we just see a few outliers down here. This one looks good. I'd probably go with means. I know you can also look at the histogram right here. Do not look at these. These are the permutations. So the permutations down here on the bottom give us the p-value. Can anyone estimate the p-value for these tests in the chat? Here's the random chance results. Here's our result. Can anyone estimate the p-value from the chat right now? This is also what you should know from this output. Yeah. P-value is instantaneously 0 because there are no results that are as extreme or more extreme than our result. And so we can see right here in the output, all of these p-values are going to be 0. So every single one of those p-values is 0 because there's no result as extreme or more extreme than ours. There could be questions like that coming up. Stay tuned here. Let's check out that next question. Let's see who's going to win. See, you guys are doing great. I want to know from the people who win, what has been your strategy and what you've been doing. Good to have you here, Patrick. If the relation between two variables is monotonic and linear, which option should you pick? Oh, I love this answer. I love this question. This is a really good question. We have two variables. They have a monotonic and linear relationship. QQ, straight enough, no outliers. Is there a good way to help remember if it's normal enough or not? You have to look at the QQ plot. If it's straight, or the straighter it is, the more normal it is, the more bent it is, the more not normal it is. And we do try to use extreme examples. We do try to make it look kind of obvious. This one we covered in office hours lately. The answer is to use Pearson. Wow, I'm very happy. I'm really happy. Don't worry if you got it wrong. Don't worry if you got it wrong. Your 5-year-old pretends to love to drink coffee. I was drinking coffee in church. I love church for that reason. I was like, I go to church, I get to drink coffee. That was the only time I drank coffee as a kid. I think they made me drink the decaf, and I would just put a bunch of sugar in it. Little did I know cream makes it amazing. I mean, I was like, this is good with sugar. I'm drinking sugar water that tastes weird. But yeah, you put the cream in the coffee, way better. Exactly, Adam. This one right here, we have really good notes for this one from office hours. I'm going to pull up those notes. We talked about this during office hours, and we're searching. Here we go. So here is some review notes. We review briefly here, but please swing by office hours. Please ask questions. But with all this right here, you'll notice that Pearson is going to be no regrets. Yeah, Jensen, you're doing a great job. Like, thank you so much, Jensen. like for being here, 201 practicing. If you see, there's a lot of, Jensen, because you are 201, right? Do you see the overlap between 201 and 320? We go into like greater detail on stuff where in 201, we learned about Pearson correlation, which is linear. But in 320, we're learning about Spearman correlation. Now, I like to draw it with the S shape sometimes, but it does not have to have an S shape. What is a requirement for Spearman? Spearman must have a what relationship to use Spearman? This is a requirement. What is a requirement about Spearman? Yeah. Great, Jensen, you're doing excellent. It must be monotonic. And monotonic, remember your favorite band. What's your favorite band? Everyone put your favorite band in the chat. What's your favorite band? I was like asking this question. People were like, Ben Folds 5. And I'm like, well, yeah, that's a good band. Ben Folds 5 is awesome. And they haven't been around for a long time. Now they came back for a little bit. One Direction. Everyone knows your favorite band's One Direction. That's what monotonic means right here. Monotonic means one. No, it's your favorite band's One Direction. Maroon 5. And Adam Levine's awesome, but One Direction is better. So monotonic means one direction. It can handle outliers. It can handle heteroscedasticity, and it can handle nonlinear. So linear is always monotonic. Heteroscedasticity. Well, so if it was heteroscedastic, like the points can have a sort of form like this. The relationship can be monotonic and heteroscedastic with outliers. So what do you notice here? 201 especially, heteroscedastic is just another name for the what? Heteroscedastic is just another name for the what? When we talk about heteroscedastic right here, we're talking about what? Is he? I don't know. Did I say that? Heteroscedastic is just another name from 201 for what? It's like the very complex term for unequal spread. But in 201, we call it plot does not thicken. So in 201, we want the plot does not thicken. So a heteroscedastic relationship is one that has differing spread. A homoscedastic relationship is one that has the same spread. So homoscedastic is going to look like equal spread across, and heteroscedastic can look many, 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 many ways. Like heteroscedastic can go thinner. So heteroscedastic is going to be differing spread, where homoscedastic is same spread. So does that make sense? Like equal spread versus different spread. Heteroscedastic is differing spread, like different for hetero, and homo means same. So heteroscedastic versus homoscedastic, just a little bit on those terms right there. I have the stars on these because these are required. It must be linear to use Pearson. It must be monotonic. So you may have been tricked on this one. You may have thought, wait, he's saying it's monotonic, but all lines are monotonic. All lines go in one direction. A line cannot be non-monotonic. So it's a little bit of a trick right there to add monotonic to that. But, you know, just lines are monotonic. So the fact that it's linear, it is monotonic by default. So really good question. Yes, Mubot is correct right there. Love the quotes. Great job, great practice right there. Really good concept and a review of different types of correlation to use. Correlation shows strength, direction, form, unusual features. The 4 features of correlation. Quiz question. What is the lowest possible p-value? Oh, that's too easy, Brian. Come on. We can do better than that. What is the lowest possible p-value? Really easy. P-values are the probability of our results or results more extreme happening by random chance variation given that the null is true. The p-value is the probability. So 201, if you just did probability, this is a great review of probability because probability is contained between 2 numbers. Probabilities cannot go outside of this range, and a p-value is a probability. So with a p-value being a probability, a p-value must be contained between 0 and 1. P-values are contained between 0 and 1. Now, the lowest possible correlation is -1. So correlation is between -1 and 1. I might have that one next. I'm trying to remember. But p-values can only go as low as 0, which would say what you observed was impossible. If you see an estimated p-value of 0, I love that right there. It's a great quote. If you see an estimated p-value of 0, it's saying we estimate that your results are impossible, because do realize that R often shows you an estimated p-value. Mubot, we're just chilling. Why you gotta be like that, Mubot?
I am Mubot.
There he is. Wonder Swan leading the way, jumping up the leaderboard. I don't know. This is close competition. Puppet Shark, are you ready for the next question? Yeah. Puppet Shark is ready. Let's do this. True or false? Correlation implies causation. Puppet Shark, what do you think? Mubot, what do you think about Puppet Shark's answer?
I am Mubot.
Ooh, Mubot didn't like that. There's some hints. This is classic. If you don't know this line, oh gosh, no. Hero Urchin, is that you? Jump up the leaderboard. This is classic. Correlation is not implying causation. Please tell me I didn't get this wrong. Oh gosh. Oh, I'd lose. They wouldn't let me teach if I got that one wrong in the Kahoot. They'd say like, Brian, you're gone. No more teaching for you, Brian. So correlation does not imply causation. There's a lot of stuff, you know, we talk about, does everyone remember the, what's his name? The Nicolas Cage example. Like Nicolas Cage is highly correlated with deaths in swimming pools, but like the more movies he's in, the more people are dying in swimming pools. Not the Beast, you get it. But no, that's just by random chance actually. And then there's things like summertime. Oh, excuse me, not summertime. There's things like shark attacks and ice cream sales. That the more shark attacks there are, the more ice cream sales there are. The more ice cream sales there are, the more shark attacks there are. But that's actually due to a what variable. Review concept here. So here I'll draw it out. The way it works when we have this type of variable. So this is another concept we should definitely know. This will come up also in multiple regression. That sometimes it looks like X implies Y or Y implies X, but in truth, there's a variable we can't see right here, and it's lurking behind the scenes. Like if you haven't chatted this whole time, you are lurking. That's a lurking variable. And there's also things like spurious correlations. A spurious correlation is just probably one due to random chance that happened to come up. Like the Nicolas Cage swimming pool thing is probably spurious. There's not some real deal behind that. So to differentiate between a spurious correlation, that's just one that does happen that somehow came up to be strong enough to exist, but it just happened and it's not real. But a lurking variable is when there's a third variable. Like this is the idea of a lurking variable. This is the variable that's actually causing it. When you see shark attacks look like they cause ice cream sales, or maybe ice cream sales cause shark attacks, no. In this instance, there's a lurking variable. Hero Urchin is lurking behind the scenes, gonna do some winning right here. If you win, I'll shout out to Stat201. Make it happen. Make it happen. Ooh, leaderboard's getting tight right now. Leaderboard's locked up. Who's gonna win? Bold Giraffe. Make some bold moves. You got this. Quiz question right here. The model used as a starting point to compute the total sums of squared error is the what? Oh, I love this question. I'll draw it out here in a second. This is a model with no X variables. Didn't the movie Jaws actually harm beach attendants that summer? Probably, I bet. I know a shark that eats bathtub people. So the model that is used to compute the total sums of squares, the starting off point, the no knowledge model, the model that has no knowledge is the naive model. The naive model. The naive model is a what line? For those trying to remember, the naive model is a what line? And this will be very important as we go through to more topics. In a quantitative model, it is that. So the naive model is the mean of, thank you, Jessica. Jessica, did you take 474 last semester? So good to see you here, Jessica. Thank you so much. The naive model is a flat line. There's no X variables. Because if you think about X right here, if there was a coefficient of X, what would the coefficient of X be? Like if I write here, like y hat equals b0 plus b1x, what would the coefficient of X be? Let's throw some 50 points. You're in 474 now. Yes. 50 points for Jessica swinging by. Jessica, we're doing like group points these days. I figured out a better system, I believe. In HTT, you're right. Jessica, do you have any words of advice for them about the test or anything like that? This would be 0 right here because there is no slope. Jessica, give any words of advice you have to them for the test. Let's just do, we're at the midway point, I think. Jessica's going to give, got an 80 on my first coding exam. Awesome job. Coding night exam. I'm super proud of you right there. We're going to look at the leaderboard right here. I think this is the 10th question. We're going to hop here. Oh, that's Hacker Man. We got new things this semester. Let's hop back to the main screen for 1 second. Jessica, we're at the midway point of this Kahoot right now. Jessica, we need you to give some advice and hype them up. They're a little bit afraid. What is your advice, Jessica, here for the 320 students to do well in 320? What would you suggest? They get their test coming up on Friday. We didn't turn on full hacker man mode right here. Deep breaths, ask questions. Other people probably have the same question. 474 and other courses build upon stuff. Yes. You're Hero Urchin. You got this. I believe that's all right. That's all right, Hero Urchin. Afraid, not at all. A little scared? I'm scared. So deep breaths, ask questions. We're going to try to direct you. And for some reason, the average on the test is really bad. We'll fix it. You got this. Coding is hard. Be grateful. Do you, at the end of 320, Jessica, how'd you feel about coding? Coding's hard, but how'd you feel at the end of it? By the end of 320, was coding a lot easier? With it, I think people are starting to feel it now. And you're feel free, it was still just as hard. You can say anything. This is Jessica's advice from Jessica right here. We'll get one more bit of advice right here. And thank you, Jessica, for offering your advice and swinging by. We appreciate it. I'm gonna let the song end, then we're gonna hop back into this. I'll head over to the main screen. Jessica's gonna drop some more advice right here as we go to the next question. Let's do this. Here we go. Next question. Felt amazing. I understood stuff. I like seeing that right there. I love seeing that. Next question. Question 11. Which of the following is not a condition for regression? Ooh, which of these is not a condition for regression? What are our 3 conditions that we check? Oh, you're gonna be like, Brian, we love this condition. Thank you, Jessica. Did we get the answer right? Let's find out. What are the 3 conditions for regression? I'm super impressed. I am really impressed. That's great answers. Where do you go to check this? Help me out here. Where would Brian go? I'm typing it. Be typing in the chat to confirm. Here's the 3. Oof. That's bad. How many conditions do we fail right here? How many conditions do we fail? Nice job, Lucy. Great job. I'm so interesting. Nice job, Kayla, right there. How many conditions do we fail right here? Double check. Double check. 2. We fail linearity. And we fail... you can see it. What do you think is the main cause, and which issue are you most concerned about, and where? What do you think... which issue are you the most concerned about, and what do you think is causing it? We pass equal spread, and we fail the linearity. Right now, we just have the x variable, which is the linearity of the model, and the butter toast. We passed the butter toast, even though it's got this crazy... Yeah, that's big issue right there. So if you notice this right here, the 2 on linearity, I know, because it's right now, this is just the same one for the simple model, but in the multiple world, we'll have each individual is checked and the multiple model is checked. So it's a little confusing, but this is just the same for the linearity, the equal spread, and the normality. The outlier is completely insane, and that's probably, I'd want to investigate this outlier, and if we toss out that outlier, we might actually have a model here, but this outlier is ridiculous. And to see the outlier, you could probably look at this. I mean, it's showing up everywhere. That outlier is destroying it right here. So I am most concerned about the normality of the residuals. The linearity looks to be fine. This is cutting through. That's a buttered toast right there. It's cuts through the middle of it. So we're good right there. We are good. So excellent work. Those are the 3 conditions. The random is not a condition for this. Great work. Excellent work, everybody. Who's going to win? Groovy Tiger. I like that name right there. Groovy Tiger. Make it happen, Groovy Tiger. Residuals should be independent. Oh, we don't have the music on. Let's bring back up that music. Residuals should be independent. This means knowing one residual gives you no information about another. Might not have highlighted this enough. But you want your residuals to be independent or dependent. It's interesting because I said random's not a condition. I mean... a statistician could argue with me, because you actually want your residuals to be random. You do want them to be random and independent. So we got to hit the button. You want your residuals to be random and independent of each other. What would dependent residuals look like? If your residual plot looked dependent, I want people to tell me here, high or low. You ready? Here we go. Here's what the residual plot's going to look like. Will the next residual be high or low? Will the next residual be high or low right here? Will the next residual be high or low? This is what a dependent residual plot might look like. I bet it'd be low too. And this is dependent because we have information from one residual that gives us information about another. But what should this residual be? This residual should be anywhere on here. It should not depend on the last one. In truth, it should be anywhere, but this does look to have a dependent pattern. Sometimes you don't see it as specifically as that. A residual plot might look more something like this, where you might see a pattern like this. And then there's some dependency, especially time plots will have this. So we do not want, gambling says low, exactly. So we don't want to see a dependency right here because this one has a dependency where knowing the last residual gives you information about the previous one. So all that good stuff right here. Where will a residual plot always be centered at? Where will this line be centered at right here? Where will that line be centered at? So residual plots will always have this, and they'll usually say residual on the left side. The residual plot will always have the line at where? Because everything on the line would have this residual. Everything on the line would have this residual. That line right there has a residual. Exactly, Kayla. Great job. Has 0. So if you want to think about what the original plot would look like, you can just take your residual plot and you could just turn it. Like maybe this went down originally. So the original plot right here may have looked something like this. So this is like the line, and then turn it into a residual plot. Well, all you do is just make the line flat. Does everyone understand that concept pretty well? That a residual plot is just going to show you basically the line is now at 0 because everything on the line has a residual of 0. And so maybe the original plot, like the original model, looked something like this. So you'd be able to see in the original plot the kind of swervy pattern, but a residual plot just takes the line and makes it flat. So all that good stuff. Carter, great answers right there. Jensen, awesome job. Play responsibly. Oh, if you're heading off, Jensen, thank you so much. We appreciate it. So glad to see 201 just hanging out, doing some knowledge stuff. Oh my gosh, the leaderboard's going crazy. It's anyone's game. Who knows? Joyful Snail's leading the way. Super Dove. Super Dove's been around this whole time, but you can't stop the bold moves of Bold Giraffe. Let's see who's going to win. What is the uncertainty in the slope? Ooh, I like this question. What is the uncertainty in the slope? Squint your eyes. I mean, I do it all the time because I can't see stuff. What is the uncertainty in the slope? What is the uncertainty in the slope? When we're talking about this output, a good bit here. What is the uncertainty in the slope? This is regression output now. What is the uncertainty in the slope? So we have an estimate of the slope, and we have an uncertainty of the slope. We have an estimate in the slope and an uncertainty. Nice job right there. So what are you actually choosing right here? Uncertainty is just another word. I always call it this. Is just another word for what? Who can put in the chat? Uncertainty is just another word for what? Uncertainty is just another word for the standard error. Everyone, thank you so much for those shout outs. 20 points for Jensen right here playing along with us. Uncertainty is just another word for standard error. So anytime you see standard error, just think uncertainty. So you're thinking about the uncertainty in the estimate of the slope, which brings you this variable. Can anyone tell me what, can anyone do this mathematics in their head? Don't, just make sure, tell everyone you didn't use a calculator. I want you to divide these two numbers right here. Can anyone divide those two numbers right here and tell me, like, do it in your head though. I mean, do it in your head, wink, wink. Don't use a calculator though. Divide those two numbers and tell me what that is equal to. So divide those two numbers. Divide the estimate by the uncertainty. Snea, great work right there. How did you do that? How did you, oh my gosh, there's the answer. So the t-value is the standardized metric by which we can compare them, not in my exactly. Great job, Virginia and Linda. So this right here is going to be the standardized metric right here. Anytime you take the estimate and divide by the uncertainty, it gives you the t-value. Here's a tough question. Which of these is more statistically significant, A or B? Which of these is more statistically significant, A or B? Who knows? It's on the screen, yep. Which of these is more statistically? It is B. Why is it B? Why is B more statistically significant? So the answer for why B is more statistically significant is right there. That is the answer why B is more statistically significant. The answer for it is because the t-statistic is more extreme. The p-value and the t-statistics are inversely related, just like down here, the f-statistic and the p-value are inversely related. So these have an inverse relationship right here. So I'll put inverse right here. These are inversely related. This is the overall model test. If we could see what this p-value was, it would be the same as the what. So here's the question. If we could see what the p-value was down here, like if we could actually see this p-value on the bottom, if we could actually see the p-value, would it be the same as p-value A or p-value B? If we could see the p-value on the bottom, would it be the same as p-value A or p-value B? Would it be the same as p-value A or p-value B? It'd be the same as p-value B because the significance of the model is the significance of the what? The significance of the linear model is the significance of the what? the significance of the linear model is the, and don't worry if you get anything wrong, the significance of the linear model is the significance of the what? And there it is right there. There we go. The significance of the linear model is the significance of the slope. No worries, no worries. Just this is practice. The significance of the x variable. Nice job, Virginia, right there. And so we can see it in this one, and we can see that this right here, this is for the simple linear world and the significance of the model. Does anyone know what 63 divided by 1.3 is? Oh, there's the answer right there. So understanding this output's pretty key right here. Just practice, just practice. This is practice. It only matters when we get to the test. Do not worry. 20 points for positivity. I want to see some positivity in the chat right here. Do not worry. This is the practice. This is where we get to just make sure we got it down. More wrong answers, more right answers on the test. That's what we do. So let's go to the next question. Let's find out. Bold giraffe, bold moves. Let's do this. Next question. What is the typical miss the model makes? You got this. You know this one. You know this. Typical miss the model makes. This model is predicting the meat weight of an abalone. Abalone? Abalone? Abalone, that crazy fish creature. Or like, I don't know, it's an ocean creature that we get meat from. The meat. What is the typical miss the model makes when it predicts the meat weight of this abalone using diameter? So the model predicts the meat weight of the abalone from the diameter of the abalone. And the typical miss the model makes. Abalone is right here. The typical miss the model makes is the typical size the residual is away. And we have some really great notes on this too from class. Like, Brian, you got 10,000 sheets open. You got to close out some sheets. I don't know. We were playing Smash Bros. In class. So when we talk about the typical miss the model makes, here we go. I want you to look at this really quickly here. And please, please, please check out today's video. Abalone. How would you describe this? Remember, we did this day in class. It's just practice. When you predict somebody's test grade, this is the RMSE here, the residual standard error, which is basically a standard deviation. When we are predicting somebody's test grade, we typically miss their test grade by about 5 points. All of these individuals were predicted to make a 90 on the test. Now, this doesn't mean they will make between an 85 and a 90, but we'd say, you know, like, we typically make, oh, is it tuna? Is that all it is? It's not tuna, is it? Tuna's a fish. So we're not saying we will be off by 5. Be very careful on that wording. And you know what? Since we talked about this, I will show it. Here is the interpretation Mad Lib we made today for it. Where is it? There's slope. Here it is. RMSE, which is typical miss the model makes. And please make sure to do context. And this is R squared. So our model on average misses by blank when predicting blank. Our average misses on average by about 5 when we are predicting someone's grade. Grade would be the Y variable. Exactly, Taylor. Great work. So on average, our model on average misses by 5 points when predicting a student's grade. Yeah, and so Lucy, I would have accepted that. We'll throw in 5 points. On average, our model misses by about 5 points when we are predicting someone's grades. We don't want to say the model will miss by this. Just look at the model. It predicted and misses by about 5 on average. So, but it could, someone's grade could have been perfectly predicted, and now it's not accurate anymore. But we could just add in more error to someone else. We can make this person get an 83, and now the mathematics should work. So now on average, our model misses by 5. There's only one person was missed by 5, but if I've still done my mathematics correctly, 21, 27, and then yes, that is correct. The model still misses if you add this up. Only still in absolutes, you bet. Continuing on, who's going to win right here? Joyful Snail in the lead. Here we go. Next question coming right at you. What percent of the variation Y is explained by the variation X? This is the definition of one of them. So you should instantaneously go to a certain number. Be very careful. Oh, they're nearly identical. This is an amazing model. If you know a little bit about multiple regression, you'd say, wow. Or you'd say, they're basically identical, Brian. That's so good. It's not a multiple model, though, so we only focus in on the multiple version of this, which is weird. But we're only looking at what? We're only looking at what when we talk about the percent of variation Y explained by the variation in X. We're only looking at the what? We're only looking at the adjusted R squared. And so it is 77% of the variation. Just to make sure it times it by 100. The multiple R squared is nearly identical, but we don't really care about that in the simple world. I just want to interpret right here the slope. I'm trying to think if I did that on this one. I think I would have. But this is the R squared we use right here. This is the R squared to talk about the percent of variation in Y. There's y tilde x comma data equals, explained by the variation in x. So 76.93% of the variation in the meat weight of an abalone is explained by the diameter of the abalone. A lot of ways to interpret it, but just make sure you have a good way. And here we are with this right here. Here's our Mad Lib interpretation. So you take r, you square it exactly. So you could get the correlation. Data, is it ex3 abalone? So if you go right here and you go core ex3 abalone and you do meat weight and then you do ex3 abalone and you do diameter, there's the correlation between the two variables and you square it and there's r squared. 77, and that's a good, Lucy, 20 points. I mean, I know it sounds, there's a speed run of it right there. You take r, you square it. Lucy, good comment right there, because we should know that this is the correlation right here, which tells us the kind of, we don't really see the form of it, but correlation is strength, direction, form, unusual features. So if we did do the correlation of this, we could look at it. And actually, I can kind of quick do the correlation on this. If I go associate command right here, I can quickly get the correlation. Correlation won't freak out if I do this. Invalid formula format. Oh, because yeah. There we go. And there it is, right? Ooh, Spearman or Pearson. Speedrun, Spearman or Pearson. This is a definite. Oh, if you see this on the test, that's instantaneous something. Spearman or Pearson. Spearman or Pearson. That's instantaneous. That's Spearman all the way. That is 100% Spearman. And you can also see the correlation we calculated via the output, but that is as Spearman gets. If you said Pearson on this, I'm sorry. So it's got the non-linearity to it. It's got the heteroscedasticity. The outliers are the least of our concerns. The non-linearity and the heteroscedasticity is going to be the problem. Spearman all day, every day. Great job, Herschel, Carter. X, good to see you here. Sebastian, excellent work. Who's going to win? Make sure to email me and tell me which email. Ooh, Joyful Snail and Super Dove running away with it. Make sure to email me and tell me which email you want me to send it to. If you just want your UTK email, perfectly fine. Amazon gift cards. We're getting close to the end. Quiz. What is the correct interpretation of the slope? Oh. Which of these is the right? I will interpret it fully here in a second. Only one of these starts out correctly. Some of these make it sound like cause and effect. There's some bad words in these. I know you're looking at one. And you're like, oh, that looks kind of right, but there's a bad word in it. It's the second word in one of these. Is such a bad word, you don't want to use it. It's this one. Don't say that. That's a bad word. Don't say that. That means it will happen. There's no will in statistics, just an understanding about what could happen. Great job. This is the stat tool 1 interpretation. Don't use it. Don't use it. Don't use it. I'm going to try and make sure all the instructors grade this as similarly as possible, because I do grade this one a little tough. We don't want to say the will word, but we want to say 2 abalones that differ in their diameter by 1 centimeter. 2 abalones that differ in their diameter by 1 centimeter are expected to differ in their meat weight by 1.09 pounds of meat weight, where the abalone that has a larger diameter is expected to have more meat weight. So, and we should be able to easily create this model here so we can see it and also see it on the screen at the same time. Let's go to LM. Summary. I do want to point something out. This model, due to the way that the visualize works, will not graph properly. You can get this to compute, but if you do this format right here, if you go to visualize, you are about to see madness. If you use this format. That's why we use y tilde x comma data equals. When I update reg class, which has been on my list for a while, I didn't make reg class, you have to use this format to make it work, and now the visualized model will work, and that super confirms the linear model should not be used here. That your check regression on this is gonna, yeah, check regression is gonna not like, it's all gonna be bad. Every p-value is gonna be 0. Yeah, every p-value is 0. Every p-value is 0 on that. But we have here, let's look at the interpretation as we interpret it. Here's the interpretation of the slope. Here it is right here. So follow along. 2 abalones, which is what we're talking about, that differ in their meat weight, but differ in their diameter, 2 abalones that differ in their diameter by 1 unit of diameter, centimeter, are expected to differ in their, and we will give you units on the test, okay, let me start again. 2 abalones that differ in their diameter by 1 centimeter are expected to differ in their meat weight, y variable, their meat weight by, and this is where we put in B1 right here, by 1.0903 pounds, where the one with a larger diameter is expected to have more meat weight or larger meat weight, so larger meat weight. So hopefully this makes sense right here. Lots of practice, good stuff right here. Just practice, practice, practice. We were practicing this today. We'll practice this tomorrow. So practice, practice, practice. Tight leaderboard, tight leaderboard. Who's going to win? Questions coming at you. What is the margin of error for the diameter estimate? Oh, this is tough. It's not that bad. What is the margin of error? I do like this question. This is probably one of the tougher ones, a little more math question. What is the margin of error? See, I could put some of these directly on the test. What is the margin of error? The margin of error is the plus or minus. Don't look at the numbers with all the decimals. Always try to convert it to something easier in your brain. So the margin of error, I want someone to say 106 to 102. How far away is 106 to 102? Or 112, sorry, I can't even think today. How far away are 106 and 112? Mubarak, you're exactly right. Half the length of the interval. Great job, Mubarak, right there. So 106 to 112, how far are those apart? How far are 106 to 112 apart? So we just moved the decimals over to make it easier to understand. Kayla, great job right there. It's half the length of the interval. Anytime you think of a confidence interval right here, this is an important thing we should know because I like this question. It could be on the test. But what you're thinking about with a margin of error is half the length of the interval. So if you go here from 106 to 112, the estimate was 109. And in truth, there are decimals here, but it just makes it easier to kind of see this. And the plus or minus on this is going to be 0.03. If you didn't know, this is green. Thank you, Microsoft Word. So it's just, I don't understand it. Yeah, Herschel, and this is what we're here to do. This is what we're here to practice to make sure we get them right here. And then we can see the margin of error. The length of the interval is 0.06, but half the length of the interval. Yep. I think the visualizations can really help. Do not worry if you got this wrong. Is it going to be a leaderboard shakeup? Oh, no. Oh my God. Macho Man Randy Savage. Oh, who's going to win? Oh, yeah. That did not sound like Macho Man Randy Savage. Let's do this. Next question, true or false? The intercept can have no meaningful interpretation. Can, theoretically. See, if you're thinking through things, you're like, okay, this is one of those ones like, okay, if there's any case when the intercept has no meaningful interpretation, we're good. Think about the abalone one where we're talking about the diameter. You'd be saying when the diameter of an abalone is equal to 0, we would expect on average there to be this meat weight. So when the diameter of an abalone is equal to 0, that's the intercept interpretation right here. So we expect blank with a x of 0. We expect, did I put an extra s there? We expect blank with an x of 0 to be, we expect meat weight, which is what we're predicting. We expect meat weight with a diameter of 0 to be equal to, and this is it right here. So there's two reasons this is illogical. One, you can't have a diameter of 0. And what's the other reason this is illogical? So there's two reasons. This is double illogical. So we expect meat weight, which is what we're predicting, with a diameter of 0 to, like, when there's a diameter of 0, we'd expect meat weight to be this. Why is it doubly illogical? Because we're saying meat weight we'd expect to be equal to this. So why is that like, that's also illogical? Like, one, you can't have a diameter of 0. That's illogical. So the intercept of height and weight had an intercept with them. Exactly. That's what it means to be illogical. So when things are illogical, they have no meaningful interpretation. It's just like, you can't have negative meat weight. Exactly. You can't say, how much meat did you get from that abalone? And you're like, negative 0.26. And you're like, wait, I don't understand. I don't get this. So it can't have negative meat weight, and the diameter can't equal 0. So it's doubly illogical. Double illogical, making it happen right there. Who's going to win, though? Oh, Groovy Tiger. You can still do this. Third place is right there, and who knows what's going to happen. So the y variables fills in that blank. Just to point out where the variables are at. We expect... yes, this is the y in this version. There's other ways to interpret it too. Just make sure it makes sense. Here's another way that's not written right there. When we are predicting when we are predicting meat weight for abalones that have a diameter of 0, we would predict on average negative 0.26. Or you could say negative 0.26 is the prediction for abalones that have or the meat weight prediction for abalones that have a diameter of 0. This is what I want you to do when you write your interpretation. Please write this in the chat right now. I want you to remember this. Read your interpretation, see if it makes sense to you. Write this in the chat. I want to see everyone paying attention right here and writing this in the chat. Read your interpretation. I'm going to write in the chat too. Read your interpretation. Read your interpretation. See if it makes sense to you. Read your interpretation. See if it makes sense to you. So I'm going to read my interpretation of the intercept here. When we catch abalones that have a diameter equal to 0, I know that doesn't make sense. When we catch an abalone that has a diameter of 0, we would predict that the meat weight would be negative 2.26. That doesn't make sense. I mean, so that's illogical, but at least it's using the right components. So read your interpretations, make sure they make sense to you. So please, and thank you so much. Let's throw some 50 points. I'll just read some interpretations and I'll be like, I don't even know what this means. Okay, let's do the next question right here. Let's see who's going to win. So here we go. How many tests are failed? You got this. You got this. You got this. You got this. You know how to do this one. You got this. Remember how tests are done. They're a little bit different. How many tests are failed? You got this. You got this. I know you got this. How many of those tests? There's 3 tests. Linearity, equal spread, normality. How many of those tests are failed? 3 tests. Linearity, equal spread, normality. All 3 are failed. What is the null hypothesis for a test? What is the null hypothesis of a test? What is the null hypothesis of a test? The null hypothesis is that it's good, that we pass it. So when you think about the null hypothesis being good, you're saying, I reject normality, or I reject linearity, I reject equal spread, I reject normality. So you would say, I thought low p-values are good. No, low p-values just mean we reject the null, that our results are statistically significant. So yeah, exactly, all the tests pass. That's what we start out with. Not all tests in whole, but each individual test is done. So we start with linearity as a test. We test the linearity, we test the equal spread, we test the normality. The next step, if we fail one of these tests, is to look at the sample size to make sure we can look at the diagnostic plots. And if we have a large enough sample size, then we look at the diagnostic plots. And we've done that some today. But you know what's even better? The last question, who's going to win right here? Who's going to win? Close leaderboard. Groovy Tiger versus Bold Giraffe versus Wonder Swan, but Joyful Snail and Super Dove. See, if I was Super Dove, I might have started. Let's see. So that was good output then, Carter. So let's pause here for 1 second. That was actually bad output. Don't worry, Carter. Great question, Carter. Let's throw 50 points. Thank you, Carter, for asking that. It's not about winning the Kahoot. It's about knowing the knowledge for the test. So I want to go back and look at Carter's question. I want you to look at these plots right here and just tell me, do these plots look good or bad to you? Do these plots look good or bad to you? Like, look at the linearity. Does the line go through the center of that? Look at the equal spread. Does that look like equal spread? Look at the normality of the residuals. Does that look like normality of residuals? Look at those plots and just think about how they look. So with those plots looking like they do, they look very bad. Nice job, Carter, right there. So with those plots looking very bad, the p-values are very what right now? The p-values are very, very what? The p-values are very, very, very what now? I'm going to make a good model here. So those are going to be what? The p-values. I'm going to make a model here that actually works. So we'll see the difference. Load the data. So those p-values are very low because those plots are super bad. But this one, let's look at this. Now look at this. What is the only condition that's bad here? What is the only, don't call that. What is the only condition that's bad right here? I mean, there's an iffy one, but the only condition that's bad is where? So here's the steps. We look at this and we say, is that high or low? And that's high, so that's good. It means we pass, we don't fail. Exactly, Carter. Carter, great job, great job. And this one is the low p-value. That stands for, if you type this in, that should be point. There we go. That's what that p-value is, scientific notation for this. So this is a low p-value below 0.05. So that means we need to look at this plot right here. This is your plot for normality of residuals. This is linearity and equal spread. So with this plot right here, we see that there's a small issue down here and there's an issue up here. Who thinks this is really bad, or like, let's do 3 scales. Really bad, a little bit bad, or really good? Really bad, a little bit bad, or very good? Which one of those would it be? And so this is the only one we fail down here. It's a little bad. Like that's not good right there. That's not good right there. So that's not good right here. So with this, we only fail one condition. It's a little bad, but not too bad. So pretty good. I'd probably use that regression. I'd use it. Because what? Oh, it might be the last question. I shouldn't ruin it if it is. I'm trying to remember. Oh no, here's the last question. After we fail a test, what is the next step? Oh, you got this. You got this. We already commented on it. I hit that. I forgot it was the next question come up so quickly. After we fail a test, what do we do? What do we do if we fail a test? What do we do if we fail a test? What did we just do? The next step is see if the sample size is larger than 25. That's what we do right there. And then we check the diagnostic plots. So sample size greater than 25. Who's going to win? Oh my gosh. Congratulations, everybody. Really good review. Let's find out who's going to win. I want you, if you won, let's just go out and give 100 points to everybody. If you won, Wonder Swan, amazing work. Super Dove, but leading the way the whole time. Close game for the 2 up there. Joyful Snail, who won, and what have you been doing to have this knowledge? 20 out of 20. 2 people got every question right. That's awesome. X, thank you for the positivity there. You know what? We're just throwing another 100 points. I don't care. I appreciate this. Oh, wait. Really? Oh, because I hit enter? I wanted to listen to the music. We got our own music. Let's put on some music right here. Put on some music. Go back to space. Joyful Snail. Kayla's Joyful. Did you win? Where's the results at? Was the Joyful Snail was the winner? Oh, go back to the podium. Kayla, did you win? Wonder Swan. Super Dove. Kayla. Congratulations, Kayla. That is amazing right there. Kayla, do you have advice or strategies for anyone? You're Super Dove. So you're second place. Great job, Kayla. Who got first? I am Super... Oh, wait. Mubarak was Super Dove. And then Kayla's Joyful Snail, right? So I'm glad this was helpful right here. Drop some advice. Drop some advice. Wonder Swan was HTT. I have a formula sheet and use my office hours memory. Thank you. Like you're seeing right here, office hours. Be dropping advice to people. What helped you out? And then I do want to know how people do on the test. I mean, I can see that obviously. But it goes, I think it leaves the podium quicker these days. Yeah, Kayla, amazing job. Already watch every lecture, office hours video, and I have my cheat sheet with me right now. Mubarak's doing the same thing. He's got his cheat sheet right beside him. So I really think, we see this all the time, and I'm going to send out a survey to 320 students. I think a huge thing, office hours are what helped me on this Kahoot. I joined late, but only got about to run. Nice job, Adam. Great job, Adam. And the test is going to be a lot similar to this. The test is going to have a lot of similar questions. The interpretations at the end, oh my gosh. Please know your interpretations. Please know your interpretations. Please know your interpretations. Please know your interpretations. What percent advice? Go to class, participate, go to office hours, read the slides, and ask questions. Yeah. The biggest thing, I don't want to feel like, I love this class. I love this class. And I just don't want you to be like, I have to do so many things. The more you do, the more it helps. And the more you interact. Like, if you come to office hours and you ask questions, if you come to class and you ask questions and answer questions, then I think that helps a lot. So it's about advice, reading good sheets besides including interpretations. It's a really good thing. I think people are working up on a cheat sheet together, which you're allowed to work on cheat sheets together. You know, you can't like take the test and then say, hey, put it on the cheat sheet. Don't do that. Like, you know, don't go to it and say, hey, this was on the test. Don't do that. We want people working together in productive ways that help people learn the material. So all this good stuff here. I've got my Word document, email, very question. Yep, exactly, Mubarak. Exactly. Even if you lose a few points on a quiz or anything like that, just email me. Also, answer people's questions helps a lot too. Yeah, ask each other questions, answer each other's questions. Just here's my biggest bit of advice. Please, 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 if you're stuck for more than like 5 minutes, please email somebody. Like email me if you're stuck, if you can't get something to knit. Will I email you back? Sometimes it takes a moment because I'm like teaching or doing things like, so usually, and thank you, Rory. We'll hold off here in like 1 minute after this song. Will I email you back? Will Brian email you back? Will he help you out? I've probably failed somebody. The gut is powerful, but the data is more powerful. I will email you back. I will respond to you on Discord. Sometimes it just might take a moment. It might take me 6 to 12 hours sometimes, but rarely. Hopefully it's not one of those circumstances. It just depends. Like test days are closer. Thank you, Caroline, so much. Yep. And so put things in Discord, put message out there. Hey, I don't understand this. Can someone explain this? Does anyone have this? But please put it out there, and I try to respond to everybody as quickly as I can. So yeah, and thank you. Everyone's awesome right here. All this positivity. Let's throw out 50 more points. We're just going crazy with points. Show up to class, get those points. They are worth up to 2 points on your final grade. Kayla, you're awesome. Thank you, everybody. I'll get on the group me. Roderick, exactly. Any last comments as we head off here? We got 1 minute and 17 seconds before we head off. Any last comments? Last comments. Any last comments of the day? Throw some positivity out there for everybody. What time are office hours tomorrow? Let's pull that up. Office hours tomorrow. Brian will be available in office hours tomorrow, so join in live. Ask those questions. I will probably focus a lot more on the 320. Here's office hours tomorrow. It should be available behind me. I'm going to disappear. We'll end with that. We'll end with office hours tomorrow. It's a good spot to end on. That's it. That's got the office hours. So you can't really see it that well. Yeah. Well, okay, we'll get the main screen. There we go. Hopefully you can see it there. There's the office hours. Office hours tomorrow from 11:30 to 12:30 and 3 to 4:30. Why does it say when the first one you get a chi-squared error? That can happen with some data. It's just a warning message. No worries. I would like to advertise the butter. Sure. Evenly spread butter toast. Evenly spread butter toast. I'll play one more song right here. Sometimes you can get the chi-squared error when data is a little bit odd. If you want to double check, email me and I'll be like, nothing to worry about. So Linda, feel free to email me if you're worried. And I'll be like, nothing to worry about. Roger's like, hey, Linda, what's happening? If you're worried something's gone wrong, you can email me to say like, hey, Brian, did I do something wrong? And I'll be like, no, it's fine. Don't worry about it. If you're like, how do I solve this? I'll be like, but I can confirm there's nothing crazy going on if you want. Like send me a screenshot and everything. So I just send you a message with my email. Also, did we just earn? Yeah, let's do some Mew bucks. I'm gonna hop back to space here. 2 seconds. Let's do something. Yes. Mew bucks. Let's go 1,000. Let's go 1,500, 250. Who was? Can you guys help remind me who was the other people? Kayla, destroying it. I know you're like, I gotta do it. I want to see it. I want to see who's the highest after this semester. Who was the other? Mubarak also won second, right? I think Mubarak's second. Make sure to email me with your email address that you want it sent to. You don't have to email me from me. You can just say send it to this email address. Mubarak was second, and HGT. Thank you so much, Lucy. Lucy, you are getting an extra 100 points for helping out right here. HGT gets the 250. I'm just rounding them up. And Lucy gets an extra 100 for thank you so much. Lucy also doing an amazing job. Everyone's doing an amazing job. I always break the point economy. Start the counter. Let's do this. There we go. I was 12th. We'll throw out another 20 points for positivity right here. That's what we do. Thank you, Lucy, and thank you, everybody. I think that's got it. I'll head off here. I'm gonna get some dinner. So enjoy, everybody. Have a great evening. Snay, that's so... Don't worry. It's practice. Ace the test. Review the material. Good practice tonight. But get ready. Practice, practice, practice. I'll be moving up a tier in office hours tomorrow. Yes! Make it happen. Make it happen. Next tier. Here we come. With that, everybody, it's time to go. Cliff, you're welcome. Keep up the great work. Keep up the great work. Message me on Discord if you got any problems. I'm gonna head off. I'll eat some dinner. Bye for now, everybody. Bye! Bye, Roderick. Bye, Cliff. Bye, Kayla. Bye, Adam. Bye, Snare. Bye, Lucy. Bye. Bye, GT. You're welcome, Christopher. Keep up the great work, man.